Hello guys, this is Aarthi from S Kumar Views and I welcome you all to this session. I have created many popular courses on our channel. You will want to develop a cool project after learning the basics. All you have to do is hit the subscribe button and the bell down below so you don't miss any of our new lessons, and don't forget to share this into your friends. Today, we are going to see some examples of the Python programs on mathematical functions with explanations. So please keep watch till the end. This is a Python program to form an integer that has the number of digits at the tens place and the least significant digit in the ones place. Problem description is that the program takes an integer and forms a new integer which has the number of digits at the tens place and the least significant digit in the ones place. Problem solution should be like this. First, take in an integer and store it in a variable. Make a separate copy of the integer. Using a while loop, calculate the number of digits in the integer. Convert the copy of the integer and the count of the number of digits to string. Concatenate the last digit of the integer to the count and convert the new integer back to int. Print the newly formed integer. Here is source code of the Python program to form an integer that has the number of digits at the tens place and the most significant digit in the ones place. The program output is also shown on the screen. Now I would like to explain about this program. First, user must enter the number and store it in a variable. A copy of the variable is made because the original value of the variable would be changed for counting the number of digits. The while loop is used and the last digit of the number is obtained by using the modulus operator. Each time a digit is obtained, the count value is incremented. The number of digits of the variable and the number is converted to string for ease of concatenation. Then the last digit of the string is obtained and concatenated to the count variable. The new number formed is then printed. That's it. This is a Python program to read a number n and print an identity matrix of the desired size. Problem description is that the program takes a number n and prints an identity matrix of the desired size. Problem solution should be like this. First, take a value from the user and store it in a variable n. Use to for loop, where the value of j ranges between the values of 0 and n-1 and value of I also ranges between 0 and n-1. Print the value of 1 when I is equal to j and 0 otherwise. Here is the source code of the Python program to read a number n and print an identity matrix of the desired size. The program output is also shown on the screen. Now I would like to explain about this program. First, user must enter the value and store it in a variable n. The outer for loop enables j to range between 1 and n-1, as n is not included, while the inner for loop also enables I to range between 1 and n-1. For each iteration, the value of 1 is printed if I is equal to j and value of 0 is printed otherwise. The September and n parameters of the print function help in formatting, and print function allows values to printed in a new line for each iteration of the outer for loop. That's it. This is a Python program to find the roots of an equation. Problem description is that the program takes the coefficients of an equation and finds the roots of the equation. Problem solution should be like this. First, take in the coefficients of the equation and store it in 3 separate variables. Find the value of the discriminant, d. Use an if statement to check if the value of the discriminant is greater than 0 or lesser than 0. If the value of the discriminant is greater than 0, use the quadratic formula and find the roots rounded up to 2 decimal places. Print the roots of the equation. Here is source code of the Python program to find the roots of an equation. The program output is also shown on the screen. Now I would like to explain about this program. First, user must enter the coefficients of the equations and store it in 3 separate variables. The value of the discriminant, d, is found out, which determines the nature of roots of the equation. If the value of the discriminant is lesser than 0, the roots are imaginary. If the value of the discriminant is greater than 0, the roots aren't imaginary. The value of the roots is found out using the quadratic formula. The roots of the equation are printed. That's it. Thanks for watching. Have a great day.